Hello, today we're gonna take a look at one of the questions from Singapore Mathematical Olympiad that was given for the first round of a junior section. I'll give you a second to read the question and then we will get started. Okay, so in this quadrilateral we know the length of this side, this side, this side, and the length of this diagonal. And we know that the angle BAD, which is this, plus the angle ACB, which is this, going to give us 180 degrees. So these two angles add up to 180 degrees. Okay, and we have to find the ratio of OD to OB. Well, let's write down the angle. Right, so this is angle alpha, right? So this is the angle alpha, and this is the angle beta. Let's call it beta, and they add up to 180. I'm gonna split angle alpha into alpha 1 and alpha 2. Just you will see later why I'm doing this, just for convenience. Okay, so now let's look at these triangles, right? So this triangle and this triangle. So let me first draw the height of this triangle with respect to this base, their bases here and here. So this, if this is a height, then for triangle AOD, right, for this triangle, area is going to be equal to half of OD times the height, or half AD times AO and the sine of the angle between this. Similarly, for the triangle AOB, area is going to be this height times this base divided by 2, or this side times this side and the sine of the angle between them divided by 2, right? Now, if I'm going to take the ratio of these two areas, you see that I will end up with OD over OB, and that's exactly what I need to find. So OD over OB, because H and H cancels out, 1/2 and 1/2 cancels out, is equal to AD times sine alpha 1 divided by AB sine alpha 2, because AO cancels out, 1/2 1/2 cancels out, and we know the lengths of these sides, right? So it's 4 and 6. So OD over OB equals to 2 sine alpha 1 divided by 3 sine alpha 2. So if I know these values, then I'm done. Okay, but I don't know these values. So what am I going to do? Well, I'm going to try to find those values. So let's look at the triangle ABC. Okay, so this is ABC. And I'm going to write down the law of cosines for the angle beta, right? So the length squared, so that's opposite to angle beta, has to be equal to these two lengths or two sides of the triangles squared each, summed together, minus 2 times their product and the cosine of the angle between them, right? So this is a law of cosine. 6 squared equals to 5 squared plus 3 squared minus 2 times 5 times 3 times cosine beta. And from here I can find the cosine beta to be just negative 1 over 15, right? So straightforward. That, so you can already tell that beta has to be bigger than 90 degrees, because this is coming out to be negative 1 over 15. I mean, it's not relevant to this question, but just so you know. And I'm gonna continue looking at this triangle, and I'm gonna write down the law of cosines for this angle. Then what do I have? Now, the side length that's opposite to this is 3, right? So 3 squared has to be equal to 5 squared plus 6 squared minus 2 times 5, 6, and the cosine of this angle, alpha 2. And from here I can find the cosine alpha 2 to be 13 over 15. Okay, so, well, I don't know sine alpha 1, I don't know sine alpha 2, but what I can do is I can find the values of the sines from this for beta and the alpha 2. Sine beta is just going to be equal to square root of 1 minus cosine square beta, right? Because of the identity sine square alpha plus sine square beta has to be equal to 1. And if you work this one out, we get 4 times root 14 divided by 15. Similarly, for sine of alpha 2, we get 2 times root 14 over 15. Okay, so I have my sine alpha 2, but I do not have my sine alpha 1. How do I find sine alpha 1? Well, sine alpha 1 is equal to sine alpha minus alpha 2, right? Because alpha 1 and alpha 2 has to add up to alpha. So sine alpha 1 is nothing but sine of alpha minus alpha 2. And I know that alpha is 180 minus beta, right? From here, because alpha and beta add up to 180. So I can write the alpha as 180 minus beta. And minus, of course, here alpha 2 minus alpha 2. Now, I can rewrite this as sine 180 minus sum of beta and alpha 2. And sine of 180 minus any angle is equal to the sine of that angle, right? We know that. Now, this is just sine beta plus alpha 2. Well, we're gonna write down, we're gonna express this using our trigonometric identities. Then this is gonna be sine beta times cosine alpha 2, cosine beta, sine alpha 2. And notice that I know what sine beta is. I know what cosine alpha 2 is. I know what cosine beta is. I know what sine alpha 2, right? So I just plug in the values, corresponding values for sine beta. For example, I plug in 4 root 14 over 15. For cosine alpha 2, I plug 13 over 15, and so on. For these also, their corresponding values that we already calculated. And this thing ends up being 50 times root 14 divided by 15 squared. Okay, so now I know my sine alpha 1, I know my sine alpha 2, right? So I have these two values, and I can go and calculate this ratio. So OD over OB is equals to 2 sine alpha 1 divided by sine alpha 2. Sine alpha 1 we already know from here, and then sine alpha 2 we already calculated it earlier here. And if we calculate this, we're gonna end up with 10 over 9, and that's the ratio of OD to OB, and that's the answer to the question. I hope everything was clear. Thank you.